All right, so we're transitioning into the world of polar coordinates. There's kind of three parts to what we're doing. There are the just plotting points and just the idea of converting between XY coordinates. And then plotting a point with a theta, a direction you face, and an r, radius, that you walk in that particular theta direction. And then there is the graphing, like the curves, where there's a defined r. The radius is actually a function itself, and it makes these really cool kind of swooping curves that look like circles and curls, as we talked about in class. And then there's rose curves and these things called cardioids. And there's also taking an expression written in a rectangular form, like y equals 3x plus 2, and then converting that to a polar form that graphs the same thing with r's and thetas, and vice versa. An expression has r and theta in it, and then writing in that form. So this is just part one, where you get to the idea of graphing, just a singular point. Now the grids are the same in these two pictures. The point 4, 5 is graphed in both of them, but the one on the right is a polar coordinate system, which is just putting concentric circles through, the points 1, left, right, up, and down, and 2, a radius of 2 means it goes through 2 over, 2 up, 2 down, etc. And the difference is we can describe that point instead of 4, 5. We can also describe it as a theta and an r. And theta we're doing with our, just like we did when we did stuff on the unit circle. We need to know the radius, which is going to be x squared plus y squared square rooted to get the hypotenuse, just like we did in vectors. And then theta is going to be an angle we get from doing inverse tangent of the y coordinate over the x coordinate. And then you just have to be careful that that angle is in the correct coordinate. So you have to think about that solution. Actually plotting the point is important, so you get the right angle. If it gives you the wrong angle, like it's facing the opposite direction, just add 180 to it to correct. Okay, so we get a point. Instead of 4, 5, it's the square root of 41, comma 51.34 degrees. And those are equivalent. They graph a point in the same location, just in a different way. Okay, so down below you're getting this idea that the r is the distance from the pole. We called it magnitude when we did vectors and we drew an arrow. Well, in polar we're plotting a point at the end of turning a direction theta and then walking at a distant r to plot a point. And it's always a distance from the origin is what r stands for. When you do polar graphs, you have to start with the angle. So it's your input, and then, which is on the right-hand side of the coordinate system, which is, it's aggravating that it's like that, but it seems backward. And so, but you have to remember, you start with theta, you have to face a direction before you walk a certain number of units if you're going to be accurate about where you land. Then the second, the output is actually the first in the list. So you start with an angle like pi over 3, and then you're going to walk a radius 2 as an example A. So we're facing pi over 3 and walk out 2 rings, which is a distance of 2, just like if you walked 2 to the right or 2 up. With those rings, you can walk in any direction an exact length of 2 units, whatever your measure is. Okay, and then B, of course, is face 7 pi over 6. So I mark the angle and walk out 4 units, which is 4 rings out, and then so on. So there's C. Now C is interesting, negative 45 degrees, just backing up, and then you walk out 3 units, 3 rings. And if we go to D, D is the interesting one, the first that has a negative radius. You're facing 3 pi over 4 in that second quadrant in the upper left, but you're going to walk backward 1 unit. And you can see that marking on there, 1 ring, but walking away from the direction that you're facing. So face the angle, walk the radius. Forward is positive, negative is backward. And E is the same thing. You're facing 0 degrees directly right, but you're going to walk backward 4 rings and plot your point. Okay, so that's the basic idea of plotting points. Now, because we're dealing with angles in a circle, like on the unit circle, we have many ways to face a direction. We have infinite coterminal angles, which means you can actually plot a polar point in an infinite, or describe the point. Now, we're all talking about the exact same point. The point doesn't change, but how you can describe it or write it can be done in an infinite number of ways. So for instance, if you're going to face the angle pi over 3 and walk out 2, I kind of plotted a pseudo version of that. If you're facing it, your radius is going to be positive 2. But if you add 2 pi to that or subtract 2 pi from that, you're going to get something that's facing the exact same direction. So you're going to get a different angle measure, but it's going to be facing that exact same direction as pi over 3 by adding 2 pi or subtracting 2 pi. And then you're going to walk out 2 units. All of these plot the same points. So if you can imagine, is you can add or subtract multiples of 2 pi to any angle, and you're going to be, and then walk out a given radius, and you're going to land on the same point for any one of those. So you could just say essentially plus or minus k2 pi to any angle you have, and you're going to be talking about facing the same direction. And then if you put the same radius in front of it, you're plotting the same point. You can also face away with a negative radius. So, I can do -2 radius if I add pi to my pi over 3 that I'm given for that point. That means I'm facing the opposite direction but walking backward. So adding pi is like going and facing the opposite direction 180 away, or pi radians away, and then walking backwards. That's an equivalent, and that means if I face that angle 180 away, that pi away, or any coterminal to that, then a radius of -2 will land me on the point, the given point that I plotted there at the beginning. So I could also add pi or subtract pi, and I'll be facing opposite. But in that case, if I'm facing away from the given point, then I'd have to have a radius of 2. In this case, you notice that if I just add any multiple of pi, I'm going to be landing on a point that faces away. And again, I'm adding this pi to the original given angle of pi over 3, so you can choose. And so I made a common denominator whenever I add something to 2 pi or pi to an angle. I make sure I have a common denominator, and that's what I've notated down there if you look at the small print. All right, that's the idea of plotting points. I'm going to give another video here shortly about the remaining ideas that happen.